So in this video, we're going to talk about working with some integrals involving e to the x. And so the first thing we realize with e to the x is that e to the x is its own derivative. Therefore, when we do the integral of e to the u du, it's just going to be e to the u plus a constant. It's just going to be e to the u plus a constant. What would you differentiate to get e to the u? You would differentiate e to the u plus any constant. Okay, and so that's the key for integrals, is we have to have the same thing. The derivative of the exponent has to be tagging along for us to carry the integration through. Now, if it's just integral of e to the x dx, then that's just e to the x plus a constant. But if it's something other than x, we do have to deal with the substitution, reversing the chain rule. So let's consider an example here. Here we have the function integral of 5e to the 3x. So if that was just 5e to the x, we'd say, hey, it's 5e to the x plus a constant. We're done. But now our exponent is not just x, it's a 3x. So here we have to do our substitution step. You recognize our composite function as e to the u, so let u be 3x. And then realize that du calls for us to have a 3 to go with the dx. So as we begin to work this problem out, I need a 3 in there with the dx. Have the variable part. I don't need an extra variable or anything. So I just need the 3 there. So remember, we can do that. So the 5 can come out front. We can do that by putting the 3 with the dx as we need it, but then accounting for that, since it's a number, by dividing by it on the outside. So we're actually going to have 5/3 outside, e to the 3x, and then put the 3 that we need with the dx. That way, by multiplying by 3 on the inside, dividing by 3 on the outside, we have not changed anything. And now we can carry the integration through. I'm going to do this the long way here. So I'm going to go ahead and change over to u. So I'll have 5/3 integral e to the u du. And now that's ready made for our integral formula. That's just going to be 5/3 e to the u plus a constant. And then we substitute back in for what u is. We know that u is equal to 3x. So we get 5/3 e to the 3x plus a constant. One of the reasons that I've taught this integration by substitution the way that I have is so that now you can start leaving some shortcuts, or start taking some shortcuts. Right? When we realize, hey, I have e to the u du, rather than actually writing that down, knowing how the integral of e to the u works, and this is the same with ln, knowing how those things work, once I have it set up, e to the u du, I can just carry the integration through and skip out this e to the u step and just jump down to 5/3 e to the 3x plus a constant, because I have it set up so it's ready to carry the integration through. So we could do the substitution and write it down, but the reason for doing it this way is so that we don't actually have to convert over to u. We just set it up. We use u as a structure to help us frame it so that it's fitting, everything fits together properly. But then we can just carry the integration through because we have divided out by 3 on the outside there. We ended up dividing by that derivative. And now just do the antiderivative of what's left, and that's the 5/3 e to the 3x plus a constant. Okay, so we're going to look at some more examples in another video, but this kind of gets the main idea down for how to deal with integrals of e to the x.